Hello students, I'm Satyendra and I'm going to explain you about Rutherford atomic model. So my first question is that what is Rutherford atomic model? See, Rutherford did experiment known as alpha particle scattering experiment, and due to which he was able to observe the position of electrons and proton inside the atom, which totally contradicted J.J. Thomson theory of an atom. Okay, so if I talk you about alpha particle scattering experiment. So there are three major components. The first one is alpha particle emitter, the second one is a gold foil, and the third one is a fluorescent screen. So my first question is that what is alpha particle? Yes, you are right. You may be familiar with the helium atom. It has an atomic number of 2 and mass number of 4. And if we remove 2 electrons from the outermost shell of helium, it will be ionized and it will become helium plus 2 charged particle. Okay, so this is called alpha particle. Now the second component is gold foil. So why Rutherford chooses gold foil? Because Rutherford wanted the foil to be the super thin, as much thin as it can be compared to the thickness of 1000th atom. That is why he chooses gold foil, as gold is the most malleable element known, right? And third one is the fluorescent screen. It is made up of zinc sulfide. And what is the property of the fluorescent screen? That if any charged particle after passing through the gold foil strikes the fluorescent screen, then this fluorescent screen will glow, right? So this was the three components of the Rutherford experiment, that is alpha charged particle experiment. But before this experiment was performed, the model which was popular was J.J. Thomson model. So it was expected that most of the alpha charge particle after passing through the gold foil will go to the other side and will strike the fluorescent screen. But the observation of the experiment totally surprised the scientists. And what was the observation? The first observation was that most of the alpha charge particle passed the gold foil without any deviation. That was okay. But second observation was that some of the alpha particles shows some minor deviation. That was still okay. But the third one, which surprised the scientists totally, was that only few of the alpha particle, that is one among 12,000 alpha particle, which we can compare, strikes the gold foil, and the alpha charge particle rebounded back to the original path. That totally surprised the scientist, that how can this be possible. So to make you understand the concept little better, I will take the help of one analogy so that you can relate with that concept, with that analogy, and understand the concept. Okay, so you can see this figure. This is a figure of the barbed fence fire, and if I tell you to stand to the other one side of the barbed fence fire, and you have to throw 1000 tiny balls to the other side of the wire. So if I ask you what is the chances of the ball to cross the other side of the fence? Yes, you're right. You will say that maximum number of time the ball is going to cross the fence. Yeah, and in fact, more than 90% of the times it's going to happen that the ball will cross the other side of fence. What is the reason? Because there are large number of empty spaces between the wires. Okay, and that's why it is going to cross the other side of the fence. And some of the times, sometimes it will happen that if you throw the ball, it will pass to the nearby region of the wire, and if it touches the wire, there will be some minor deflection. And very few times it will happen that if you throw the ball, it would directly impact the wire and it will return to the original path in which it was traveling. And that's it. That's the analogy. From this analogy, now I'm going to explain you about the conclusion drawn by the Rutherford. Rutherford draw the conclusion that the most of the spaces inside the atom is empty. Why it is like so? Because more than 90% of the rays shows no any deflection, and the positive charge nucleus is concentrated in only a very small region inside the atom, right? So if I draw the Rutherford model of atom, so I will draw a nucleus, and inside the nucleus I will draw a proton, and after that there will be a large number of empty spaces, large area of empty spaces. You can see that this is the empty spaces where there is no any charge particle present, and after that there's a outermost cell in which electron will revolve around the nucleus. So this is the Rutherford atomic model. But was Rutherford atomic model totally true? No. Why it is like so? Because Rutherford was not able to explain the stability of the outermost cell. Why it is like so? Because if we know that electrons are revolving around the nucleus and it is accelerating, if this electron is accelerating, so it will radiate energy. And we know that if anything radiates its energy in a circular path, slowly its energy will decrease and this path will become a spiral, and a time will come when this electron will collapse inside the nucleus. And so by this theory, how can electron be stable? So is this theory right? No, there was one minor contradiction which was explained by the Bohr. And what was that contradiction? Let me explain you. Bohr explained that Bohr explained that there is only a fixed orbit. There is only a fixed orbit in which electrons keep revolving around the nucleus, and that orbit is called discrete orbit. And if the electrons revolve around the nucleus in that discrete orbit, so the electron will not radiate in any energy. And if the electrons doesn't radiate in its any energy, so the energy will not decrease and the electrons will keep revolving around the nucleus in that discrete path. This is all about today. So this is all about today. This is all about the Rutherford model. So thank you so much.